Well, we're going to give this a shot, everybody. Welcome to FMT100. This is Unit 4, Module 4. This is the lab, and we're looking at prints. Well, the title, Industrial Prints and Print Reading. So, what I'm going to show you and trying to get you to start thinking is, while we've gone through and we've kind of showcased these are the different prints are out there that are made, uh, I want you to understand that you will be asked from time to time to create your own prints depending on what's going on. And where I went to school, we pretty much started that right off the bat. But day one, we were basically drawing and sketching and tracing out systems. And when you trace a system, when you follow an existing system and you create your own drawing based off of that, you create a better understanding of the system. So that's why they had us do that. So you can create a drawing, a print for your own use doing the same method. So one of the things I had to do is I had a commercial cruise. That's what this binder is. And it was aboard the research vessel Miller Freeman from NOAA. This vessel has since been regrettably scratched. So that's the drawback there. So yeah, kind of sad. I miss that vessel. She was a cute one. Really liked her lines. That's why I have this image on the basically showcasing it. So I go through. This is my project. But what I really wanted to get to was all the drawings. And I'm going to have to switch this around a little bit. So this is my title block's way the heck up here. So this is the fuel oil system. So these are all the different tanks. These are all the different valves and the manifolds going in. We've got some fuel purifiers. We go over to our main engine here. We've got boilers, two auxiliaries. These happen to be the auxiliaries happen to be generators. So remember, on a ship, you don't have a grid. You are the grid. So you create your own electricity, and that's what these are for. So I traced this out following the piping that was there, and yes, I affectionately was known as bilge diving. So I went in and dug up deck plates and moved them around so I could trace out lines and such like that. So this is the fuel oil transfer and the service system for it. This is a really nasty rough draft of it, but it's a little bit more detailed. It shows you some of the crossovers going in. So they have two different lines, suction and discharge. So here's a suction line. This is a discharge line. So you can transfer coming off of your purifier as well as your filters and everything else, including your engines. So this is our air compressor system. So ship service air and control air. So we don't. When you start a diesel engine this size, you're not just turning a key. You are literally pushing a button, and that button is opening up a valve to allow air pressure, pneumatics to go in, and it's air pressure that pushes on the pistons and get them starting, and then you switch over to fuel. So that's what we've got here. We got two air compressors. We got lead lag control, a cooler so we can cool the air, get a better charge out of it, and we just keep going on. So we got different air receivers here, reduction station, so reducing down from 150 psi to 100 psi, and then another reduction station from 100 psi down to 15. And got a pressure switch and say, hey, we need to start the compressor and everything else. Uh, this is the controllable pitch prop. So this is the sum of the components with that. they had a particular type of prop that I was not allowed to copy much of the information, but this is what I was able to come off with. And here's our tank, our pumps. This is our servo. The servo would determine which way the pressure inside the shaft had to go to control the piston for the props, pitch of the props. Here's steerage. I know, not as impressive. So on either tank, is directly attached to the tank is a 15 horsepower pump and motor. And then we go up. Here's our rams, and our rams are fixed at one end, and then go to the rudder post. And it's these rams working tandem that twist the rudder post and steer the ship. Lube oil and cooling system for the reduction gear. Oily water separator, because you just can't pitch used oil and dirty oil overboard. You've got to collect it and whatnot, and some of that oil has water in it, so we want to separate the water from the oil, so that way we only have to collect dirty oil. So that's what this was. Then evaps, and everybody's favorite, the refrigeration system. So as you can see, we've got drawings for just about everything. Well, it wasn't just the Miller Freeman I went to and worked for while I was at Cal Maritime. Part of the other deal was I needed to go out to industry again, and this time I went to San Francisco State and basically got an overview of the place before I even started working there. So let's just cut to the chase, go right to the drawings here. At that time, San Francisco State did have an operating power facility, and because it was a large diesel engine, well, dual fuel, they also had start air. You see it's a little bit simpler than the other one. And we still have a fuel system. So we got tanks on the outside, we got a pump, filter system, a day tank, another filter. So we went into this side was our primary diesel fuel. This side was natural gas with a diesel pilot. And it just kind of went on from there. Here's the lube oil system. The lube oil system was tied in, and we were trying to pull heat off the lube oil system to heat the campus. That's pretty much what this one is also trying to do. Now this one was this was the fire extinguisher, fire suppression. This is the sewage system. And this would be considered a one-line drawing. So this is from all the sinks and toilets, goes into a sump pump. That sump pump pumps into the lift station, and then we've got two pumps that do a lead lag, and then it goes off to wastewater treatment. So this is it. This is a simple line drawing. This was supposed to be a load trace for you pick a motor, and it turned out to be not so great. Now I also was able to get a copy of the single line drawing for power distribution. This is the 12K lines for San Francisco State. And right here's our substation. That's what this line here, it's separating us out. And where do we go here? So here's our meters. We come across, and then we can start going to our different buildings. So way down here at the bottom This is creative arts building, the fine arts building, humanities, way down here in the bottom in the shadows. And here's the switches that they could switch and determine where the power is coming from, what side. So this is one of the big benefits of a single line drawing. You're able to pull that off. You start looking, okay, I can switch here and still get power from these other places. And that's where the benefit of a single line drawing is. And it didn't stop there. I got even to do ladder logic. So this was a project that I took on. They were having a problem in one of the labs where a chamber, basically a lab area, that they had a lab going on, an experiment going on, and it was short cycling their compressor for the air conditioning for this one place. So I looked at it. Their controls were all hardwired. There was no PLCs or anything with it. Well, a timer, but I wouldn't call it a PLC. So I looked at it and go, hey, if we change up the relay logic a bit, we can improve the duty cycle, and it would stop short cycling the system. So I ended up rewiring it with approval, of course. I didn't just do this willy-nilly. So I rewired it and was able to show, yes, an improvement. Here's my little write-up for it and everything else. So that was boring stuff. And once again, I still did this while I was still a student. So do not let anybody say, oh, well, you're just learning, blah, 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 blah. Yeah, tell them to go take a short hike off a long pier. Now, once I started working at SF State, and everything got goofy because I started doing more drawings. So this is the pool system. This is kind of a hybrid. It doesn't show everything, but it shows it's like a souped up one-line drawing. So it gives you the main process. So if we start here at the suction for the pumps, we come in, go to our first pump, which is the supply from the pool. We go to a filter tank. From the filter tank, we go to the return pump. We go through a flow meter to say how much we're moving, a heat exchanger, and then back to the pool. So this would still be part of a single line drawing for this system. And then, yes, I've got additional systems on this. This is part of the sanitation. Well, this is part of the sanitation system. It's CO2 to keep the balance. Here's our chlorinator. So this is one of the drawings that I did for the pool, and I did this one for. This is part of the handbook for the technicians that had to work on the pool. The other drawing I did was for a retrograde for the covers, so the pool would stay in compliance with the law. And so this is an elevation. So we're looking at the side, and the scale for this drawing is 1/4 inch is equal to 1 inch. So if you were to take out a ruler and use a ruler, and I just had a ruler, dang. Anyway, you could do it as, okay, so every 1/4 inch gives me an inch, or you could use what they call an architect scale, and that's what this is. And you find 1/4 inch. Well, here's 1/16 of an inch here. All right, and upside down it's 3/32. Here's 1 inch, but on the other side of 1 inch is 1/4. So here's 1/4 of an inch, and here's 0. So how this works out is, so this is 0. Here's a 1/4 inch, but it's 1, 2, 3, 4. So we're looking at 4 inches. So let's find a nice line. Let's do 18 here. See if I can get it right here. So I'm looking at this line here. I put the 0 on the line. And I'm like, oh, so here's 18 inches, but I've got a cheat. I can go up here. And if I go to the halfway mark, and that's my half-inch mark right there, and that'll bring me up to 18 and a half inches. So now I don't even have to do any conversion. The scale has already done that. So once again, even though you quote maybe a student, do not be put off by drawings. Start working with them, start messing with them. All right, start reading them as you get up to a drawing, as you come up to a diagram. Check it out. All right, you are going to be using them. Make them part of your life, and get used to drawing them. No, I'm not saying you have to do something like this, but you can do some of the other sketches and such that I showcased. Those are still drawings. All right, and they are perhaps at times more beneficial because you've done them, so it has more meaning to you, so you know what's going on. So once that's pretty much it. Just wanted to showcase all that for you. Just keep going, and even though that was all for work, don't think that you can't do it for your private life either. So these are this is another elevation, but this is for a suggested fence post construction for the farm here that I'm on. So this is the drawing that I had done for the proposal of that. All right, so this is another elevated drawing, and yes, I go below the ground and I show how the suggested material is going to be for the base of the post, how we're going to cement the post in, give support to the gate while it's resting, the T-post, the entire shebang. And I've got copious amounts of notes up at the top. I've kind of done a little twofer here. So I've got two different types drawing styles here on this one. So this is a dimensional drawing. And it's easy to see because I've got dimensions on it, and this is specifically they would say it's a single dimension, but because I'm looking top down, this would be a top view. So for the wagon, I said this is a wagon we build. So showing how the stringers and how they're going to be laid out, the dimensions for those. But then on the side, I went to an isometric to show you three-dimensionally how I expect everything to be notched so where they rest and how they're going to lay in relationship to each other. So just because you're doing one style doesn't mean you can't flip to another. And in this case, I was able to stick two different styles all on the same sheet, and that's still legit as well. All right. So the big takeaway with this one, don't be afraid of doing drawings. Don't be afraid to start giving it a shot. All right. And also, last but not least, how to use a scale. So once again, this is an architect scale. And here's the half-inch side. So if I were to go over to this drawing here, where the scale is, well, you can't even see it that way. It's washed out. Nuts. It's half-inch to 1 inch. So the scale, here's the half-inch. The scale is just a handy way of saying, okay, this post here is going to be 10 feet high. Sorry. It's going to be, dear Lord, it's going to be 10 foot high, 10 foot long post. So this is where the scale is really nice. And that's going to be the big takeaway. What is a scale? Why is it nice? All right. Catch you all later.